Well, hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always it is an honor and a privilege to be serving here today, as it is every day here in my virtual classroom. Step on inside. I don't know if you want to step on inside here. I think I'm allergic to my own room. I haven't sneezed all day. And then I came in here for like 2 minutes to set up shop. I sneezed like 5 times. I probably now sound congested and nasally. I'm going to have to pause for sniffles and sneezes and stuff at some point, I'm sure. I was perfect up until now. That being said, apologies for that. Let's keep going. Chapter 10 on circles. I want to know if you're ready. Are you ready for this stuff? 50 question review. Let's take a look and see what we got. If you want to download this thing, check the description section down below, find that PDF, and check the timestamp for each problem. Now, if this is part of the Big Ideas Math Integrated Math 2 textbook, as I am looking right now, the first, technically second topic, the second topic of stuff is actually, for Big Ideas Math Integrated Math 2 textbook, I think it's technically the first section in chapter 11. So find the stuff that pertains to you. I believe just the very first stuff after we name diagrams. I'll pop this up right now and show you what it is. This very first page has naming diagram stuff. Right after that, area and circumference. We don't cover that in this chapter 10 stuff on circles. Why? I don't know. I think it would be a long chapter then. I see how it fits more with chapter 11. I do. It makes a lot of sense. But anyway, you can skip these probably. After that, central angles and onward. And I think it even does graphs at the very end. Great. We're ready for that thing. So if you want to take a look at this thing with me, awesome. I want to know if you are ready. Let me pause and get the sniffles taken care of. Okay, so now I've done reviews before. I've taught at the times. 50 questions. Don't want to be here for 2 hours. That being said, it would only be 2 point something minutes of problem. This problem number 1 is going to take a little bit of a moment, but I want to say things as fast as I can. So here we go. Part A, center. The center is labeled where the center is there. It's P. If you call it, this is called circle P as well. It's named by its center. Radius from P to M, that works. You can also technically do P to N and P to L. You can do anywhere as long as there's a segment drawn. If I made up my own segment, I could say P to K, but I'll leave it. That's from center to end of circle. Diameter is something, let's focus on this one right here from N to L, and it is a segment as well. Goes through P, it's a diameter. Chord, let's do one that's distinct, that's unique, like ML, from M to L. We could also do L to K. I know that there's more to that, but let's just add that one. Remember, make sure you're putting segment bars as long as it has endpoints. L to N is also, I'm just going to add that, right? That was our diameter. It is a chord. It says give an example. I'm giving multiple so you understand. Secant. Secant, KL would count, but when we're kind of, there are no lines here. We have to talk about secant lines, but it should really exist outside of the circle, and it goes through afterward. So J to L. From J to L sounds like a really good one to, I wish it was a line so I could talk about it more. But a line that hits a circle at 2 points. It hits at K, it hits at L, JL works. I'm going to use that one. Tangent. This one is one that hits a circle once. So from J to N, and then it kind of just kisses and bounces off. So JN would be considered a tangent. That's an N. Central angle. That's an angle formed at the center. So you have like this angle right here, or maybe this angle right here, or you have the whole thing. Let's, I'll label these two. So you have angle NPM. Remember, P has to be the vertex, or it's the middle letter as the vertex. And then angle MPL. There are other versions, the straight angle, stuff like that you can do. But as long as it's made by the center, with the center. Inscribed angle is one where the angle's on the circle. And hopefully it goes to another end like an intercepted arc. So I'm looking at this one here, KLN, right there. So angle KLN. And there are formulas that we have with these things. And then NLM right here. This is another one. Not necessarily congruent, but angle NLM. Minor arc. Minor arc number 1 is an arc that's less than 180 degrees. And by the semicircle of 180 right here, we can tell what would be one. By the way, semicircle is going to show up here. Minor arc also uses 2 letters. So we got a few. We got this NM. We're going to use this arc symbol like that. ML. LK. Whoops. Arc. And then KN. By the drawing, it looks like K to M would also apply. Let me just do that last one. Because it doesn't look like it goes that way. It looks like that would be a major arc. Major arc, I'm only going to name like one example because I'm going to run out of room and there are a bunch of them, but it's got to be more than 180 degrees. So imagine the semicircle plus more. So from N to L is 180 plus that L to M. So how about NLM? Arc NLM as an example like that. Now I could have also called it NKM and it would have been the same thing. As long as you use 3 letters and it goes the longer circuitous route that touches another point, you have to name that point in the middle. Semicircle, there are 2 of them that we can tell. NKL on this side, NKL, and then on this side, NML. Both 180 degree measures. They go to the diameter. We do use 3 letters. We don't just say NL, because then we don't know which way we're going with it. All right, there's number 1. And like I said, if we're going 2 minutes of problem, I lost the pace. And these ones, we got to use a calculator. Let me sniffle again. Hold on. All right, let's go to topic 2 on area and circumference, numbers 2 through 5. We look at this circle for number 2. We're going to find the area and circumference of the circle to the right. I guess it's worth mentioning now the area of a circle is pi r squared. That's the radius. Circumference is either diameter times pi or 2 pi times the radius. Double the radius, then multiply by pi. I'll round. I'll leave my answer in terms of pi, and then I'll go and use the calculator to round it. I might not always go to the calculator to show you, other than here's the pi button, and here's what you do. So area and circumference of the circle to the right. When I see the 16.6, it looks like the diameter to me. When you divide that by 2, and you get the radius, you're going to get 8.3 meters. So 8.3 meter radius, which will help me for the area. So the area of this guy, I don't know which colors to use. I kind of jump around the different colors here. So pi times 8.3 squared. Now, I do not know 8.3 squared, so I'm just going to try that in my calculator right now. 8.3 squared. 68.89. So this is exactly 68.89 pi square meters. Now, if I use my calculator to do it in terms of pi, I will multiply this thing by pi, and then I get this one. Now, they didn't say what to round to. That's kind of why I like to use the exact answer, and I would use it anyway to show you what the calculated version is. So I'm just going to go to the nearest tenth. It's around 216.4 square meters. And because it's area, we are using square meters on this one. So this is a great answer. I think that's the best answer. This is a great answer as well. I like perspective and knowing what it is without pi, but sometimes you just can't deal with it. Circumference, diameter times pi. Remember, we already have the 16.6. We might as well use it. So 16.6 pi times pi meters. And this is a length, so it's single dimensional units. Now, if I do round to the nearest tenth with the calculator, I'm going to do 16.6 pi. And I get 52.2 about meters. That's a 5. 52.2 meters. So yeah, that's an either or thing, and that's both of them. Number 3, find the radius of a circle with a circumference of 106.81 centimeters. If we use our c equals 2 pi r formula, this has circumference and radius in it. We're going to find radius by we're going to solve for radius by plugging in c. So circumference is 106.81. And if we divide both sides by 2 pi, remember they're multiplying by radius there, then it's gone here and divide by 2 pi here, we can get what that thing is. Now, because pi is an irrational value, I'm sure that this one is going to be some weird rounded thing, unless somehow that was also using 3.14, but that's approximated. So I'm just going to use the exact version. Now, if you're using a calculator like me here, what you'd have to be careful with, when I type 106.81 divided by 2 pi, you cannot do this. Most calculators are going to frown upon this part because they're going to divide it by 2 and then multiply that result by pi, not the 2, the division of 2 times pi. This answer is going to be somewhere in the 160s, 170s, something like this, right there. Boom. It didn't get smaller. Why not? Because it multiplied by pi. What you have to do is wrap those values around parentheses, because pi, you want pi to be in the denominator, so it needs to look like that. So what's the answer? I don't know. 16 point, okay, so it looks like it was intended to be 17 centimeters. So we're going to use that. Radius is about, I'll just say that, 17 centimeters. It's more like this. The original problem creator who made this problem likely used 17 as a radius, got a circumference, rounded it to the nearest hundredth, and said, okay, now find me my radius. That makes a lot of sense. They didn't guess and check numbers here until they got something close to 17, if that makes sense. All right, that was it for that one. Number 4. Find the diameter of a circle with an area of 95.03 square feet. If we use the area formula here, area is pi r squared, we can go off and get the radius. The diameter will be double that of the radius. So we're going to use these two formulas. Get the radius first from the area. Let's see if it's kind of like a, close enough number to something like that. Now here's the thing. I will not round that radius area first. I'll round diameter part afterward as a whole. But let's just figure out kind of what they were trying to target here. So we are going to divide both sides by pi. Right? And then we're also going to take the square root of both sides because I'm kind of short on room here. I'm just going to try and do that right here. We're going to divide both sides by pi. And remember, if you're in the chapter 10 stuff that the Big Ideas Math 2, whatever textbook is, you're not even doing this stuff until chapter 11. So maybe I can point to the stuff for you again. But this is where you get r by itself, right? This is where r, it's exactly 95.03, assuming that's probably a rounded number, over pi. So let's type that in the calculator, see what's going on. Square root of 95.03 over pi. It looks like they were going for 5.5, but I'm not going to round that yet. Of course, when I double it, I'll do the rounding, and it looks like it's going to be about 11. So diameter is going to be about 11 feet. So let's go back. So r is about 5.5 feet. As we double that, diameter is about 11 feet. See, once we go from area and square feet to that length, we are getting single dimensional units. Number 5, find the circumference of a circle with an area of 254.47 square inches. So we're going to go from our area formula, pi r squared, to then the 2 pi r. So let's go with that. Let's say 254.47 equals pi r squared. If you saw what we did last time, we did take the square root of this divided by pi. So I'm going to keep that going like that. Let's just leave it exactly like that. Let's not round yet. Let's go straight into that and say circumference is 2 pi times this radius. So circumference is 2 pi times that number, square root of 254.47 over pi. So this is what we want to do in the calculator. No, these pi's do not cancel because one's inside a square root and one is not. So let's do 2 pi times the square root of 254.47 over, whoops, that's 7447 over pi. All right, so it's not a perfect value of any sort of, oh, you know what? This is not in terms of pi. So I'll do it in terms of pi 1. Both of them will be rounded though, because when it came to what we had, but 56.5 inches is one answer. Sorry, I'm writing it. If we just multiplied by pi at one point, let's divide by pi to at least see what it would have been in terms of pi. See, because that looks like an exact, what they were going for, around 18 pi. So they kind of had a plan for that in mind, I guess, because the radius would have been, I guess, around 9. So here's what I put. Circumference is around 18 pi inches. That's more or less their intention. When rounded to the nearest tenth, we get that. So follow the boxed stuff, and then we're good. Okay, now if you're just tuning in to topic 3, this is where stuff from the Integrated Math 2, Big Ideas Math Chapter 10, really does kick off outside of topic 1, naming the things. Let's find central angles. Number 6, find each arc measure. I did make mention on how 2 letters represents a minor arc, and 3 is either a major or semicircle. Let's see what we got. Measure of arc CD is right here. In order to find that, we can see that a central angle of 90 degrees should be equal to the measure of its intercepted arc, this entire thing. BC is already 50 degrees, so CD will be 90 minus 53, and there we'll get that. So 90 minus 53 is 37, so we get 37 degrees for the measure of arc CD. Measure of arc AB is here. That does not look like 90 degrees, but it looks like this is a semicircle from E to EAC. Right there, that's all 180. 79 and 53 are involved. Let's do 180 minus this 79 plus 53. 79 plus 53 is 132. 180 minus that is 48 degrees. So 48 degrees. And you know what? It might help for me to actually write these in because it's possible that we use these values later. So 37 degrees here, 48 degrees there. Let's keep going. Measure of arc ED. It's this guy. Everything here adds to 360, but of course there's a semicircle right here that adds to 180 as well. So 180 minus 37, I think, is the ticket. 180 minus 37, that's 143 degrees. Okay, now we have every measure filled out. Let's figure out what else we need here. E to B is the minor arc version, 79 plus 48. And that is 127 degrees. From BDE, this is a BDE major arc. Now, I'm going to go in the route of the 180 plus 53. I think that's just faster for me to say. 180 plus 53 is 233 degrees. And then lastly, measure of arc DEC. DEC is everything but the 37. Everything is 360. Everything but the 37 is 360 minus that. So 360 minus 37. And that should be 323 degrees. All right. If I made a mistake, I apologize. I feel like I attacked everything the way I was supposed to. And that's topic 3. Oh, more on topic 3. All right, solving for x. We still have central angles involved. We got to solve for x here. I'm seeing a semicircle, 180 degrees. These two add to 180, and we set it up that way. 45 plus 6x plus 33 equals 180 degrees. Combine these guys, and you get 78. Subtract 78 from both sides and divide both sides by 6. You're going to get x equals 17. There's a solution for x. Number 8, find the measure. You know what I should be doing? Give me a moment. For some reason, I don't seem to do it as much here, and I guess I gotta remind myself to bring this up each time. I want to have this little circle guy. I like to point to which problems I have. Sorry I wasn't doing it earlier. I'll try and remind myself to keep it up. All right, number 8, find measure of arc EF. EF is this guy right here. Now, in order to find this, remember, it'll be supplementary. It'll form a semicircle with, say, GF or ED. So it's important that we find either one of these. Now, these two will be congruent. When diameters intersect each other like this, these become vertical angles that are congruent. Central angles congruent to their arc measures, equal to their arc measures. So those arcs are also congruent, or the measures are equal. We got 13x plus 3 equals 15x minus 7. Subtract 13x from both sides, add 7 to both sides, and divide both sides by 2. You get x equals 5. Not nearly the answer, but I'm just going to box it. Let's substitute 5 for x into one of these. So the measure of arc GF, for example, is going to be 13 times 5 plus 3. That's 65 plus 3, which is 68 degrees. Now, the measure of arc EF is going to be 180 minus that, because these two make that semicircle. And that'll be 112 degrees. Okay. All right, there's number 8. Let's move on to numbers 9 and 10. This is topic 4 on arc lengths. If the circle below has a radius of 15 centimeters, find each arc length. Okay, this is also not in chapter 10 stuff from the Big Ideas Math 2 textbook stuff that I would do, or Integrated Math 2 textbook. This would also, I think, be in chapter 11. So find each arc length here. Find the arc length of VW. This is not a degree. We are actually finding how long this thing is. Now, in order to do this, it says we have a radius of 15 centimeters. Let's put that somewhere. How about right here? 15 centimeters. In order to do this, what we have to do is figure out what, I mean, we do need this arc measure. I will say that. We need the arc measure, because whatever portion this is out of 360 degrees is how long this is out of the circumference of your entire circle. And because I haven't taught chapter 11 yet, I don't know which way they introduce the formula, which way they write it. I'll show you the proportion and show you what you can do off that as a whole. Let's first figure this out. Yx is 26 degrees, and we just saw another problem where this would be opposite. That's also 26. This is a right angle. That means this is a right angle here as well, a semicircle. So 90 minus 26, the measure of arc VW, is 90 minus 26, which is 64 degrees. Now, that's not the answer. But if I use the 64, this is 64 degrees, and 64 out of 360 is the ratio. It's the proportion that we set that this will be equal to in its circumference. This arc, not the arc length. Yeah, the arc length. Let's call it x. This arc length is out of the entire circumference of your circle, which is 2 pi times your radius, 2 pi r. 2 pi times 15 is 30 pi. Let's put that. In order to solve for x, I'm going to multiply both sides by 30 pi. I'm going to do times 30 pi here and times 30 pi here. So let's see how much I can do by hand before I do anything else. 30 over 360 is 1/12. So I could also rewrite this x as 64 pi over 12. And that can reduce even further by becoming 32, 16 pi over 3 centimeters. That's an exact answer for x. Again, that was all fraction reduction. 30 over 360 was 1/12. The pi still exists. 64 over 12. I divided these by 4 and I got 16 pi over 3. I'm not going to round to the nearest tenth for some of these. I just ran out of room. Time kind of sneaks up on me with this as well. Let's keep moving forward. You can try the calculator for that if you'd like. If it asks me to round or if it seems most reasonable to do so, I will. Let's move forward to number 10. Measure of arc UXV. UXV means this entire thing right here, which means the major arc, it's everything but the 26 degrees. So 360 minus 26 is going to be 334 degrees. We are going to take this portion out of 360, but if you notice what we do here is we take the ratio out of 360, let's just call this y. We take this ratio out of 360 and we multiply it by the same circumference that we had. And that's where I imagine the book will go. They might reduce because it's 2 pi r, they might divide the 2 in 360, reduce that to 1 over 180. But let's multiply by that same 30 pi here, which means this is still 1/12. That means this is 334 pi over 12. And 334 doesn't divide by 4, but it does divide by 2. You get 167 pi over 6. Now I feel more like I should get the rounded answer for that kind of thing. But that's super long, right? But it works. It works for that length. All right, that's numbers 9 and 10. Let's go to topic 5 on chords and arcs. Number 11. I don't even know how many pages this is, but I know it's 50 problems. If measure of arc DC is 12x plus 7 degrees, it's back to measures, and this is actually back to like the big ideas math, integrated math 2 stuff. If this is 12x plus 7 degrees, and measure of arc CB is 18x minus 23 degrees, they want to find the measure of arc DAB. That's this guy here. They said find that. What they show you, this is kind of interesting. What they show you are two chords that are both equidistant from the center, the perpendicular kind of thing, and the tick marks indicate that. That means these chords are congruent to each other. And two chords congruent to each other in the same circle share congruent minor arc bits. That means I can set these two equal to each other. And even if you didn't know that, it's probably something that you either assume or say, it looks close enough, why don't I give it a shot? So we will. We'll solve for x. We get 6x equals 30 divided by 6x equals 5. Not the answer. We are going to use this x equals 5 and substitute it into either of these. I'll just go ahead and do this one. Measure of arc DC is going to be 12 times 5 plus 7, which is 67 degrees. Now, I need the measure of arc DAB. I need to take all of 360 and subtract this 67. And remember, this is the same. This will also be 67. So the measure of arc DAB is 360 minus 2 67s. 2 67s is 134, and 100, this is 334, right? And 360 minus 134, I need to think about it after I write. 360 minus 134 is 226. I hope. So 226 degrees, let's kind of box the whole thing. That is the measure of the arc, not a length, just the measure of the arc. Number 12. If GP equals PH, this goes back to the equidistance thing. So these are equal to each other. That means these chords are congruent, okay? GA equals 17. I wonder if I can fit all this. Measure of arc ED is 37 degrees. Okay, I didn't anticipate using that. Measure of arc AB is 87 degrees. Find each measure. Oh, right here. I was like, what? Just find everything? All right, DB, the length of DB, where are we? This DB right here. All right. First of all, these chords are congruent. AE is equal to DB. AE equals DB. I want to make sure you know that. And, because a radius is perpendicular to this chord, it's also bisecting this chord. These two are congruent. These two are congruent. So it's 2 17ths. That's 34. Length of EG from E to G. Oh, 17. So yeah. I feel like it was better to answer that part first rather than dB and kind of go along the way, but that works. Measure of arc dB. Arc dB is right here, and keep in mind, these two are the minor arcs of these two congruent chords. This dB is equal to AE. So these two, unknown, I'll call them X for a moment. These two are just some X's that are a part of the entire thing that adds 360. 8737 plus the two X's equals 360. So, combine like terms, 37 is 124. Subtract 124, you get 236. Divide by 2, you get X equals 118. 118. So measure of arc dB. dB is the same as that AE. This is 118 degrees. Each of those separately have that. I don't know how to choose which colors I do. Sometimes I switch, sometimes I don't. Measure of arc FA. Where's F? Oh, right here. The X is kind of covering it. Measure of arc FA. So this whole thing was 118, right? This arc is getting bisected the same way, this from E to A, the same way as this chord got bisected. So you take the 118 and divide by 2. 118 divided by 2. And that'll be 59 degrees. Measure of arc DC. Where's C? Oh, that's also blocked. Measure of arc DC is also 59 degrees because they're congruent. This guy's bisected in the same way. So 59 degrees. All good. Okay. Let's go to number 13 and 14. Topic 6. I don't know again how many topics there are, but let's find each measure, shall we? By the way, I apologize if my picture ever blocks something. I'm not used to the whole thing covering this, so my bad. At some point, I hope I scroll away and you can see it and go, where'd you go? Sorry about that. All right, find each measure. Now, before I actually find anything, let me just state out loud. This diameter has a semicircle as a semicircle. This inscribed angle here is half the measure of its intercepted arc. Therefore, this is 90 degrees. If that's all 180, this is half of it. That's 90. Right triangle. Let's keep moving. Measure of arc ML. ML. This is the intercepted arc for this inscribed angle here. An inscribed angle is half the measure of its intercepted arc. So the measure of arc ML, let me actually write it up here where it is double that of the 59. Because 59 is half whatever that is. So that's 118 degrees. And I'll probably just write it down. Okay. Let's go to the next one. Measure of angle JLK. So that's this angle right here. JLK. This is an inscribed angle with the intercepted arc of 134 degrees. And I know sometimes these things are like hard to see. That's why I'm color coding, but that's why it's really good to just detect where something goes to. So we got to take half of 134, which is 67 degrees. Sorry for the bouncy red. Measure angle JLM. Now this is inside the right triangle. Listen, you have options, but I'd still have to find KL for this all to work. It's not too bad. Actually, this is 180, but I can look at this right triangle for this as well, right? Not only is JLM an inscribed angle for this intercepted arc, you can take half that if you find it out, but it's also in this right triangle where I can do 90 minus 59. The two acute angles in the right triangle are complementary. 90 minus 59 is 31. You get 31 degrees for that. Must mean that this is 62, so I'm just going to get that right now. Oh, hey, MJ. There it is, 62 degrees. You double, perfect. You double the 31. How else could have I gotten it? Actually, this would have been easy. 180 minus 118 also works. And it's just good to know that, when they introduce the numbers and such, that they all do interconnect. I think you can't go wrong, really, when they set it up. But there you have it. All right, number 14, solve for x. This is an inscribed angle, which is half the measure of its intercepted arc, so I can write that as such. 9x minus 25 equals half. This is the topic on inscribed angles. Half of this 94. Half of 94 is 47, so let's just solve for x from there. Algebra is going to go fast. 9x equals 22. Oh, no, it's not. Let's go a little more slowly, shall we? 9x equals add 25, 72. and x equals 8. The only thing that brought me a pause was 22 couldn't divide by 9. Not to say you can't have that answer, but I questioned it for a second. So, and I was right too. X equals 8. All right, let's move. Oh, I didn't highlight that. So I got to remember that. Let's get ready to copy and paste that to the next page. Let's move forward. Number 15. Measure of angle BCD is 7x plus 10. So let's label that. Degrees. Measure of arc BAD is 19x minus 50. That's this whole guy right here. Find the measure of arc BAD. You could say it's 19x minus 50. Your goal is to solve for x first and then substitute that in. So these aren't equal. Again, the inscribed angle is half the measure of its intercepted arc. And instead of taking half of this, that would mean a distribution into an odd number. Not a fan. Let's instead multiply everything by 2. Times 2 times 2, and that does mean you're going to double that entire set. So I get 14. I'd rather distribute by doubling than that half. 14x plus 20 equals, this is gone, you have 19x minus 50. And let's see if I can solve for x a little more properly now. I'm going to get 14. They do want you to find the measure of arc BAD from there. So the measure of arc BAD is 19 times 14, of which I have no idea what that multiplies to, minus 50. 14 is 280. So 266 minus 50, that's 216 degrees. 216 degrees. Okay. Okay. Number 16. Come here, you. Measure of angle PQS equals 6x plus 1 degrees. PQS, that's this guy. I'll just point to it. It's a little small. Measure of angle PRS is 34, also small. 34x minus 5x. Find the measure of arc PS. Okay, they all interconnect in such a way. PS is this arc right here. It's also the intercepted arc of this inscribed angle. But it's also the intercepted arc of this inscribed angle. An inscribed angle is half the measure of its intercepted arc. If they're both half this measure, then they're both the same. This PQS and PRS, they are congruent to each other. These measures, we get to set them equal to each other. Not an uncommon thing to hear, but you get to set them equal. Add 5x to both sides, subtract 1 to both sides, divide both sides by 11, you get x equals 3. The measure of arc PS will be found by finding either one of these angle measures here and then doubling it. Because the inscribed angle is half the measure is double of the intercept arc, it's double the inscribed angle. So let's do measure of angle. Which one looks better? This one, 6x plus 1. PQS is 6 times 3 plus 1. 18 plus 1 is 19. I have to sneeze, hold on. I'm going to pause it. Woo! Okay, sorry, that one kind of took me out. So the measure of arc PS is double the 18. So 36 degrees. The other, this angle should also be 18 degrees if you plug in 3. And yet it's not? Oh. Wait a minute. Oh, 19. Hold on. Good thing I checked that stuff. See, I say that out loud, going like, oh, I can check that. I might have said 19. I'm not sure. I had to sneeze. But I wrote 18. My bad. Maybe I was going to write 18 plus 1. So let's do that again. Measure of arc PS is double 19, which is 38. This, when substituting 3, should give you 19. It does. Okay. Sorry about that. Degrees, by the way. Okay, number 17. If the measure of angle K is 8x minus 19, I already think I see where this is going. Measure of angle M is 5x plus 43 degrees. Find the measure of angle M. So solve for x. Now, these are not equal. They don't look equal either. This is an inscribed quadrilateral. What is true about inscribed quadrilaterals is their opposite angles are supplementary. That's because they're half the measures of these intercepted arcs here and here, which add to 360. So half of those will add to 180. So 8x, there are other reasons you could state, but that's the reason I'm going to go with. 8x plus 19 plus 5x plus 43 equals 180 degrees. When we solve for x, we'll substitute it to m's expression and find its measure. So we get 13x, 43 minus 19, 24, equals 180. That's 13x equals 156, and x equals 12. So x equals 12. I've been using purple a lot lately. Measure of angle M is 5 times 12 plus 43. That's 103 degrees. 103 degrees. Which must mean 77 degrees for the other guy there. And yeah, that seems to line up. All right. Topic 7 on tangents. Numbers 18 and 19 determine if segment AB is tangent to circle C. In order for it to be tangent to the circle, this must make a right angle. That's what radii and tangents do with each other for lots of reasons. We'll just stick to that right now. 4.8 looks like to be the radius, so another 4.8 would exist right there. And that's important because what we're going to do for this, we're going to set up kind of the Pythagorean theorem. We want to see if a squared plus b squared equals c squared, as in this length plus this length equals that squared, plus this length squared equals that length squared. If true, and that's 9.6 by the way, 9.6 squared plus 7.2 squared, does it equal 12 squared? Generally, I like to think unlikely whenever it comes to like decimal bits going to an integer, but I mean, weirder things have happened. Let's see. It's possible. Actually, it's very possible. Actually, I think the answer is yes. I think this is part of a 3, 4, 5 triangle. That's, yeah. Anyway, 9.6 squared. But I just say I'm dubious in those situations. I'm kind of skeptical. But this should work out. So this is 92.16, and this is 51.84. Yep. At least it goes to a whole number. 144, and yeah, this will be 144 equals 144. That checks out. As long as a squared plus b squared equals c squared, this makes a right triangle. If it's a right triangle, that's a right angle. If it's a right angle, this is a radius. That would intersect with a tangent line. So is it tangent? Yes. Okay. Next one, same thing. The difference here is regarding markings. This is not part of a radius, but this is. So these two are congruent. If this is 11.2, so is that right there. 6.8 plus 11.2 is 18. So we need to see if 11.2 squared plus 15 squared equals 18 squared. That's the hypotenuse, right? That's the longest length among these. So 11.2 squared is 125.44. There's no reason why this will work because only one of these is a decimal, right? This is 225 and this is 324. It's just not going to happen. Doesn't matter how close it is. Looks like it's going to be 350.44. So unless I'm seeing something wrong and awkward here, that's just not going to be the case. So no, not tangent. And it's good to have one that's not tangent, I guess. But that's our test. Oh, I didn't flip over. I'm going to lose it at some point. You're just going to see me completely miss it. For questions 20 and 21, solve for x, assume segments that appear to be tangent are tangent. So now we're going for that tangent stuff, the way that it works. That does mean right angle. In this case as well, right angle. Pythagorean theorem, this is an 8, so is that. Remember the 11's on the outside, so these add to 19. So x squared plus 8 squared equals 19 squared. They want us to solve for x. 61, I think. X squared equals, that's 297. So x is the square root of 297. I do not know. I think you can divide by 9, actually. Wait, yeah? Yeah? What's 297 divided by 9? 297 divided by 9 is 33. So this can become exactly 3 root 33. You take out the square root of 9 from there, and that's all good. And get some sniffles out of the way. Okay, and this is one of those times, right? This isn't pi and stuff. I'm not going to round. We're going to leave it like that. This one is a decimal, so maybe I do. Number 21, this time x is the whole thing. They really indicate that. It's our hypotenuse. So 3 squared plus 3.2 squared equals x squared. Oh, what did I do? But this part, that's a 3, that's a 3, that's a 6. 6 squared, 6 squared. Okay, so 36 plus 1024, 10.24 equals x squared. X squared equals 46.24. So x is the square root of that. Now, there's no simplifying radicals to be had there, but let's see what that square root looks like. A clean number, it's 6.8. So there's value in doing that. No rounding. That's exact. There it is. All right. Let's go to Here, I got to paste this circle thing in. Number 22. If DE, segments DE and EF are tangent to the circle G, find EF. This is all about tangents. These are congruent to each other. Any two tangents of a circle that intersects at an external point. So we're going to set these equal. 4x plus 23 equals 10x minus 19. Subtract 4x, add 19, divide by 6. Find the length of EF, same as this DE. So EF is going to be 10 times 7 minus 19. 51. Not degrees, it is a length. Number 23, find the perimeter of triangle PQR. Well, you just saw in the last problem that tangents are congruent to each other when intersecting at an external point. So from Q to, well, there's no letter, but from Q to this point of tangent C, I'm going to kind of mark them. Q to here, that's going to be congruent to this thing. So if this is 5.9, therefore that is. I don't actually know if I need to know that. But this is 12.2. This is 12.2. This is, well, oh, okay, I will need to know that. This is something unknown, which we'll get in a second. And this is that same unknown. So 5.9, 5.9. Let's do 27.4 minus 5.9 because I want to figure out what this other guy is here. 21.5, I think. So 21.5 is this guy. That means this is also 21.5. So basically I have two 21.5s, two 12.2s, and two 5.9s. We add those, we get the perimeter. So perimeter, let's just do it that way. Two 21.5s, two 12.2s, and two 5.9s. 21.5 doubles 43. So 43 plus 24.4 plus 11.8. I really do apologize if I get an answer wrong ultimately, like I'm giving you the tools and setting up so you can go for yourself. I'm just writing down things that I'm doubling these in my head, stuff like that, and I think I'm doing it right. But you saw me. I said 18 plus 1 is 18. And I can't keep a circle with me, so let's keep moving it down. Topic 8. Angles formed by intersecting chords, secants, and tangents. Now, I talk about this possibly different from other teachers. I really like to treat this stuff. I'll give you the formulas. I'll have one quick talk on the reasoning behind how I do it. After that, I'll let it be. When chords intersect inside a circle, like this one right here, and they're going to ask for certain angles, the AED and DEC. I know this is BEC, but let me just kind of talk about it for a second. Let me expand it too. So this angle right here, actually, let me flip it for the AED. This angle right here, notice that even if I move it, obviously the angle measure doesn't change, right? Wherever I move it to, it's still that thing. So notice how this is 92 degrees as an intercepted arc. This is not a central angle, therefore this is not 92 degrees. But if I backed this up so much that it became an inscribed angle, like right there. Actually, let's do it on, let's like back it up like this. If I back it up, yeah, let's back it up like this. If I back it up like this, as an inscribed angle, it's no longer just 92 degrees. There's also this other part. You know what this other part is? This part is 140. This is also right there. So this got gained. And an inscribed angle is half the measure of its intercepted arc. This inscribed angle, measure of angle AED, the original one that's still right here, that's still measure of angle AED. It's the same measure. It's half the sum of 92 and 140. So if we see other ones like that, that's what we're going to do. Where does the 140 stem from in the original angle? It is the other side of the angle that we're talking about. Here's AED, here's 92, here's 140. Part of the BEC, which, by the way, is a vertical angle with the AED. So that's my quick talk on it, and I'm going to leave it like that. So this is half, I like to treat them like inscribed angles, basically. Easy way to remember the formulas. 232, which is 116 degrees. Measure of angle DEC should be supplementary to the 116. So 180 minus 116 should be 64 degrees. Yeah, once you find one, use that to get the other. Even if they said DEC from the jump, that's what I would have done, right? Half of that. Number 25, I did mention how inscribed angles, I just kind of showed you. I said like, hey, this is an inscribed angle. It looks a little weird going off the circle, but that's how this works. This is an inscribed angle for this intercepted arc. and this is an inscribed angle here for this intercepted arc. So we're still going to take half of certain measures, even though they're special. Find the measure of angle QST, which is this guy. In order to find that, we have one of two options. Either find this angle by taking half of 98 and then subtracting that from 180, and we will get 133 degrees. Or do 360 minus 98 to get this measure of arc QUS. 360 minus 98, and that gets you 262. And half. This must not be. Oh, I'm sorry. I never took half of. Yeah, I did. What am I doing? Let me pause for a second. I'm. Half of 98 isn't 47. Half of 94 is 47. Half of 98. I'm really glad I'm doing this two different ways, guys. I'm trying to rush, and then the rushing is not working. Half of 98 is 49. 180 minus 49 is 131 degrees. So this is 131. Okay. Or I'm really glad I'm doing this two different ways. You just don't trust me. The process is right. I can't calculate in my head. Or do 360 minus 98 to get this arc here, which is 262, and half of 262 is the inscribed angle. That'll be the 131 degrees there. Okay, number 26. I'm guaranteed to have gotten something wrong leading up to this. I just hope everything I express is good. Find the measure of angle KLM. Now this also, I just kind of mentioned it for the intersecting chords, but you can treat this guy as an inscribed angle. If I move this thing up, so you notice this intercepted arc of 51 and this one of 125. If I move it up to an actual inscribed angle, notice that the 125 is no longer 125. It's smaller. How much smaller? Well, this is 51, so is that. So we take 51 away. So we take half of some measure, half the difference of these two. So measure of angle KLM is half of 125 minus 51. So that's half of 74, which is 37. There you go. Find the measure of angle XYZ. Still the same thing. This is still an inscribed angle with these two intercepted arc guys here. This minus that. Half of that minus that. To find this, WZ, we have to do 360 minus the sum of these two. So 360 minus the sum of 136 and 68. So that's 360 minus 204, which is 156. So 156 is there. Now, the 68 is still there. So the measure of angle XYZ will be half the difference of 156 and 68. I feel like there's a faster way for me to have done that then. 156 minus 68 is 88, and half of 88, I think, is 44. That was 27. Let's go to number 28. I regret having this circle thing now. All right, find the measure of angle FGH. There are two ways to do this. One, if you know the formula, we can actually just do 180 minus 101, and boom, you got it, 79 degrees. Okay, number 29. No. The reason why that works is this 101 is not only this arc right here, but also if there was a center here, this would be the central angle, 101. And as these two are right angles, because radii and tangent lines, these both add to 180. Therefore, in this quadrilateral, these would both add to 180 as well. This angle G and this 101. So we subtract 101 from 180. That's kind of the big talk behind that. Here's what else we could do. We could also say that this angle is half of this arc minus that arc. This arc is 360 minus 101. 360 minus 101 is 259. So measure of angle FGH is half that of 259 minus 101, which is 258. Half of 158. Half of 158 is still 79 degrees. Longer route? Sure. Conventional, practical way of doing it, maybe logical? Yeah, all works out. Number 29. Find the measure of arc RU. It's this minor arc here. This is 88 degrees. Here's a linear pair with the 88. That'll be 92. 92 plus 88 is 180. So we need to find this x, the RU, whatever you put. I'm just going to put x. 92 is half the sum of the x and the 35. Because now this is the angle. So x is now a variable. It is, of course, x is a variable. It's now one of the arc measures, one of the quantities here. Let's multiply everything by 2. Again, let's not affect the x that way. So this becomes 184. And subtract 35 from both sides. And you get x is 149. 149 degrees. So measure of arc RU is 149 degrees. It's less than 180, which is expected being a minor arc, and it looks pretty big. I'm going to trust it. Number 30. Make no mistake, that right there is a secant line because they show the P and O. That does make it a secant segment, and they're trying to find the measure of arc MLP. So it's not like it's just 360 minus that. This part is just missing from the information. But this is the other part of the intercepted arc from the angle that's made all the way to P. So if I'm calling that x 75, the angle is half the difference of that x and this 91. Doubling both sides again, we get 150 equals x minus 91. And add 91 to both sides, you get x equals 241 degrees, which is our answer. And then number 31. Find the measure of arc DF. This can once again be the x. 162 is the major intercepted arc. Here's the small, or not major, but the bigger intercepted arc. Here's the smaller one. 52 will be half that difference, 162 minus x. Multiply by 2, you get 104 equals 162 minus x. I'm going to add x to both sides, and then we subtract 104 from both sides. And that x will be 58. So 58 degrees for the measure of arc DF. That's some speeding along. I'm better than that clip that I had before, like 2 minutes of problem. We'll see if that continues. Number 32, measure of arc DH is 11x plus 7 degrees. Measure of arc GF is 5x plus 9 degrees. And measure of angle GEF is 10x minus 22 degrees. Find the measure of arc DH. Solve for x, plug it in. There's the angle, half the sum of these two. So 10x minus 22 will be half the sum of 11x plus 7 and 5x plus 9. Let's clean this up because we'll get even numbers this time. Instead of doubling everything, I don't mind distributing the 1/2 into that set. Half of 16 is 8, so it can work fully there. 8x plus 8. So I combine like terms, boom, boom, took half. Subtract 8x from both sides, add 22 to both sides, divide both sides by 2. X is 15. Okay, now let's take that and find the measure of arc DH. And that is 11 times 2 plus 7, or 15. 11 times 15 plus 7, which is 165 plus 7. 172 degrees. Still less than 180, being a minor arc. Got pretty big, got pretty up there. I think that's right. Okay. Number 33. Measure of arc MOP. Okay, that guy is 11x minus 38 degrees. Measure of angle LMP is 3x plus 41 degrees. So that's this guy. We're going to find the measure of angle NMP, this other guy. So once we solve for x, we can maybe plug it into here and subtract from 180. Right? Now this is an inscribed angle for that intercepted arc. So 3x plus 41 is half of 11x minus 38. Let's double both sides this time. I'll get 6x plus, let me write that so in case people aren't like, what are you doing? How did that come up? So this is 6x plus 82, and here's 11x minus 38. Subtract 6x, add 38, divide both sides by 5. Okay, x is 24. Okay, so x is 24. Let's find the measure of angle NMP. It will equal, I take that back, let's not get there yet. measure of angle LMP is going to be 3 times 24, 72, plus 41, no parentheses there, 113. So the measure of angle NMP is 180 minus the 113, which is 67 degrees. And it kind of looks it, again, I assume these are mostly drawn to scale, making that look kind of be what it's supposed to be. Number 34, if measure of arc RU is 16x minus 13 degrees, measure of arc SU is 11x minus 24 degrees. So those are the two arcs for this inscribed angle. And STU is 3x plus 1. Find the measure of arc SU. Solve for x, put it into that one. So this is half the difference of this and this. Now here's where you have to be careful. 3x plus 1 is half the difference of, I would really wrap these two around parentheses, especially the second one when we have a difference. But let's differentiate. We have 16x minus 13 as the bigger guy. Minus, not a plus. 16x minus 13. And the smaller one is 11x minus 24. But you need it around parentheses because we have to subtract the quantity. The quantity, I have to distribute this negative. It's going to be going in like that. Now, I will be doubling everything eventually. Let's just get one more step and combine this all. So now we'll have half of, not even combining yet, 16x minus 13 minus 11x plus 24. I'm distributing the negative into there, and that's how this will go. So 3x plus 1 is half of 16x minus 11. 5x plus 11. Now it looks like I want to have the doubling effect on, so times 2 here and here. And that becomes 6x plus 2. And we got 5x plus 11. Subtract 5x, subtract 2, you get x equals 9. If x equals 9, I will find the measure of arc SU, and I will get 11 times 9 minus 24, and that should be 75 degrees. Just that little guy, just a little arc right there. Number 35 to 38 on topic 9, segment lengths formed by intersecting chords, secants, and tangents. This time we're looking at the lengths, not the arc measures or the angle measures. When they intersect inside a chord, we're going to say this times this equals that times that. That's basically the setup of these. The segmented chords products get to multiply. So 27 times x gets to equal 30 times 18. And there are ways that I can reduce. Oh, actually, this will be fine. This is 540. So divide by 27, you get x equals 20. They just said solve for x. That's all I'm going to do, and I am done. This is the same thing when it comes to multiplying. The difference is now you have quantities of values, and this is where parentheses should also be used. I have 16 times 2x minus 5. That's that segmented chord. Equals 14 times x plus 11. If I distribute the 16, I get 32x minus 80. And here I get 14x plus 154. Subtract 14x. Add 80. Divide both sides by 18, and that is 13. Okay. I know I'm going quickly. It's the algebra that I go quickly on. You should pause and say, okay, let me try it. All right, number 37. This is not intersecting inside of here. This one, here's how I say the formula. Outside times the whole equals outside times the whole. This will be the case of all those intersecting outside of it. So outside is 6. The whole is not 15. The whole is 15 plus 6. Right? Both those added together. So 21. Equals, now this outside is 7. And the whole is 7 plus x. How about x plus 7? X plus 7. 6 times 21 is 126. And this is 7x plus 49. I will subtract 49, writing 7x over there, and I get 77. And divide by 7, you get x equals 11. And then we have number 38. Also intersecting outside of here. Now I'm still going to apply the outside times whole equals outside times whole concept. Here's the outside. Here's the whole. So this is 12 times x plus 12 equals. Here's the outside. Here's the whole. They're both 18. This is x plus 12. That's 18. 18 squared. That's basically what's happening there. Distribute. You get 12x plus 144 equals 324. Subtract the 144 and you get 180. And divide by 12, you get x equals 15. Okay. 12 more problems to go. Just basically reach the hour mark. Let's keep going. Find the length of segment CD. Outside times whole equals outside times whole. 9 times the whole is 9 plus 2x minus 7, right? This plus that equals. Outside looks like that's a 7 times 7 plus 11. I just might as well write 7 plus 11. I got to do some cleanup anyway. This is 9 times 2x plus 2 equals 7 times 18. 18x plus 18 equals, that's a lot of 18s. I'll tell you what. Let me leave it as 18 times 7, because what if I just divide everything by 18? Like now instead of later. These go away and these become 1s. Okay, 18 is a common factor. So this becomes x plus 1 equals 7, so x equals 6. That's one of those things where algebraically you can go how you want, whip out the calculator and such, but if you recognize something that you think is going to help clean it up, go for it. I did. So x equals 6. Find the length of CD. I'm sorry. The last times we just had to solve for x. So the length of CD is going to be 2 times 6 minus 7. 12 minus 7 is 5. All right. Now, does 9 times, not 5, but 9 times 14, which is 126, equal 7 times 18 is 126. So yes, the answer to that is yes. Number 40, find the length of UW. We again are going to do an outside times whole equals outside times whole. This outside times whole is 6 times 6, or 6 squared. That works. The outside here is x minus 7 times the whole. Remember, that is x minus 7 plus 5. So 36 equals, we have x minus 7 times x minus 2. This is a quadratic by nature. It is factored, but it's not set equal to 0. So I must distribute this right here and get x squared minus 2x minus 7x plus 14. There are plenty of ways to solve this one. I'm going to either use quadratic formula or factoring. If factoring is available, I'm going to use that. In order to do either, I have to set everything equal to 0. So I'm going to subtract 36 over, and I get negative 22. This looks factorable. This factors to x minus 11 times x plus 2. Again, my goal is not to stick around for the algebra aspects. It's to kind of give you the geometry. So if x minus 11 equals 0, then x is 11. If x minus 2 equals 0, or x plus 2 equals 0, then x equals negative 2. Problem with negative 2 is you substitute it into here and you get negative 9 as a length, which is not possible. So I can't allow that. Neither can the problem. So x equals 11. 11 minus 7 is still positive. That works. And 4 times 4 plus 5, 4 times 9, 36 equals 6 times 6, which is 36. Correct answer prevails. Length of UW. I keep forgetting. So find that length of UW. I got it. We got, UW. UW, I thought it was UV, is 11 minus 7 plus 5, which is 9. And it does, like I said, it does work. All right, topic 10, equations of circles. This might be rounding out the end. In fact, this is the last page. So this is section 10.7 material. I think it's 10.7. It's the last section there. We have a general, I'm just going to write this one out somewhere because to use it, it's probably going to use the entire time. This is the standard form for a circle, or the equation. Like that. Your center's at HK and your radius is R. So this is the standard form equation of the circle there. Notice it says x minus h. This is x plus 2. So h is negative 2. When it comes to center, we got negative 2. This says y minus 7, and that's y minus k. So the k value is 7 right there. There's your center. The radius, r squared is 16. So r is the square root of 16. That's 4. Not plus or minus 4. Radius is always positive. Number 2, x squared plus y squared equals 121. I don't see an h or k subtracted, therefore they must be 0. The center's at the origin. And the square root of 121 is 11. Very, very quick questions to answer there. Number 43, now we're going to write the equation of the circle given the information. All of these are center, well, the first one's center and radius. So this is an x minus h quantity squared, minus negative 3 is plus, that's always a plus, y minus 4 quantity squared equals r squared. 7 squared is 49. I'm going again as pace allows me to. This center, negative 9, 0, diameter is 20. Now I need the radius. The diameter is 20, therefore r is half of that, that is 10. So this equation will be x plus 9, quantity squared, flip that, plus y minus 0, you can just write y squared equals, and r squared, which is 100. 10 squared is 100. Another diameter, which we will take half of 9, can either be written as 4.5 or 9 halves. I'll go ahead with the 4.5. If y'all don't mind. This is x minus plus 7 quantity squared plus y plus 1 quantity squared equals, now 4.5 squared, I know that, 20.25. I've seen it, I've used it, it's a thing. So that should be that answer. Let's go to green. Okay, so this radius is back here. You know what the square root of 89 squared is? Well, it's 89. So this is x minus 12 quantity squared plus y minus 5 quantity squared equals 89 as you square that. That was 46, excuse me. Number 47, we hit circumference. Now, we have spoken on circumference and area and such. So if these are problems, you don't know how the circumference stuff works, maybe your teacher's not assigning it to you, maybe you haven't seen this PDF before and whatever I'm giving it to you. So you can maybe ignore this kind of problem unless you want to see me provide you the radius. So the circumference is 12 pi. That's the same thing as 2 pi times the radius, right? C equals 2 pi r. Divide both sides by 2 pi here. Pi's cancel, and 12 divided by 2 is 6. Here's your radius. So with that center, we can say x minus 2 squared plus y plus 2 quantity squared equals 6 squared, 36. Number 48, this time we have the area. Yeah, none of these will be rounded values, right? Area is pi r squared, so 225 is pi r squared. Pi's cancel through division, I'll just leave that. And we take the square root of both sides. Square root of 225 is 15. So your radius is 15. This x minus 0 becomes x squared. I have y minus 10 quantity squared there, and 15 squared is 225. Yes, I am working fast. 2 more questions. We're probably going to finish before the hour 10 mark. When I thought the 2-hour mark was a possibility, things sped up for this set here. Well, it's going to slow down a little bit once again. And I'm going to, I don't know if I'm going to draw something. I'll do a light sketch. Negative 4, 7 is your center, this guy here. And then negative 1, 9 is a point on the circle. So that means your circle is doing something like this. We know the center. We know the HK. We got to find the radius. To find the radius, you have some options. Pythagorean theorem or distance formula are both one the same thing. I got to find the distance from negative 4 to negative 1, right? That's the x distance from here to here. That's 3, negative 3, it doesn't matter. That's 3 squared. And the distance from 7 to 9 is 2. So in Pythagorean theorem terms, 3 squared plus 2 squared equals r squared, that radius there. So I can find the radius that way. And here's the thing, I don't need the radius, I need r squared. They said write the equation. So 9 plus 4, r squared is 13. I don't even need r, which is square root of 13, but I don't need it. My center is hk, so I got x plus 4 quantity squared plus y minus 7 quantity squared. And here's r squared, it's 13. That would be it. That would be it. Negative 1, 9 being a point in the circle is 3 units away in the x direction, 2 units away in the y direction from the center. Pythagorean theorem would get me my r squared. And last problem here, number 50, a little blocked. Now not so much. Let's write the equation of this circle, same kind of thing. Find the radius, find the center, establish them. This center, if you can read this, is negative 1, negative 3. That's our HK. And the radius, we can actually do a count. I know we didn't have to graph any ourselves, but this is up 1, 2, 3, 4. It's any distance there we can work off of. That's a point on the circle. So that's your radius. So center and radius. Therefore, we get to do x plus 1 quantity squared plus y plus 3 quantity squared equals r squared, which is 16. There's the answer. And guys, that ought to do it for this one. Yes, I ended up very fast, but I want to know if you are ready. This is not a full teaching as to know if you're ready, and hopefully these answers helped you. Check out the description section down below for more. So thanks, take care, I'll see you in the next one.